So it's Thursday, the 18th of December 2014. Time for a bit of physics fun. So we're looking here at a digital oscilloscope. It's clearly got an LCD colour screen, and it's a very clever oscilloscope, this one, because it actually works out frequency, period, and lots of other things. Now, it's an amazingly complex bit of kit, but we only need to know for GCSE and A-level some quite simple things, really. So firstly, we need to look at this part down here. So if I zoom in a little, I'll show you. It tells us what the scale is. So here it's telling us that it's 5 milliseconds for each of the squares in this direction. Sometimes the squares are called divisions. The other one here says 10 volts. If I zoom out a little bit, this is the other scale. This is the Y scale. So it's a clever oscilloscope because it tells us the X scale, the Y scale, and it actually reads the frequency of this alternating trace. So here I've plugged in my lead, so there's a black and a red connector, but in terms of AC it makes no difference. One of these will be held at roughly neutral and the other one will oscillate up and down, as is shown on the screen here, between a plus and a minus voltage or potential difference. Now I have two different scaling dials here, and I'll scale one way. So when I do this, it's changed here to 5 volts per division, so I've effectively doubled the size of my graph. If I go back to 10, go down, and then we go down again, we can clearly see, and there we've got the limit, you can clearly see we can alter the scale. I've not actually altered the setting here on the potential difference of the power supply, and if we scale it back again, look, we'll go down and down again, you can clearly see a reduction in the amplitude and a reduction in the peak to peak, so that's top to bottom bit. Peak to peak, or amplitude is from the midpoint to a peak. Now, I can't change my frequency because the frequency of mains is 50 Hertz. That comes from the idea that the power supply, here we've got the lead going to the power supply and it's connected to the mains, it's just over here, a mains lead. The electricity is created from a source which is rotating at 50 cycles per second. So there's magnets in a coil of wire, or a coil of wire in a magnetic field, and that oscillates or spins around once every 50th of a second. Now there's something quite clever we can do with our trace. Now I'm just going to alter my scale slightly. Let's freeze it actually. We'll freeze it, which is a clever thing you can do with these digital ones. And let's look. So hold on, we've autoed it. We'll stop it. We'll scale it. Now we can move it around. And now then, what I'm trying to find is a whole peak. There. So I've got peak to peak. So I've got a position now where I've got from here all the way to here. Now if it's 2 milliseconds per division, I'm getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 squares there. Well, 10 times 2 milliseconds is 20 milliseconds. 20 milliseconds is 0.02 seconds. Then if I do 1 divided by time for a whole, up and a down, or sometimes easier to look at it, if we scale it again, is I always say an up and a down is a whole circle or a cycle. If we do 1 divided by 0.02, we get 50 Hertz. Now the clever thing with this oscilloscope, it works out that for you. It tells you the frequency. Now there's something quite nice we can actually look at as well. I've got 2 chemical cells here. Now if I take out my connectors and I put them now across my 2 chemical cells, so it's a battery of 2 cells, can we see clearly how if I take it out again, that line goes up, doesn't it? Now what I want to do again, let's increase my scale. Let's move it up a bit. So now we're looking at 1 volt per division. So if we zoom in a little now, let's zoom in a little. Clearly, if this is 1 volt per division, 1 volt, 2 volts, 3 volts. Well, these chemical cells normally are 1.5 volts each. If I take out one of the cells, so I'm just going to remove one of the cells here, and we put in just the one cell. So I'll put it back into the picture so we can see. Here we've got just the one cell. It's now only 1.5 volts. So you've now seen direct current and alternating current, very simply shown on an oscilloscope, and an AC power pack, which can be DC or AC, and a DC or a cell supply.